So we picked this one because we said it was the last one and it should be the hardest, but you just called it a lame problem. And why is it a lame problem?
Because 45, 90, 45.
Right. Okay. And so you already studied this triangle at length. So what can you say about the triangle? What else can I label?
That these two sides are the same, so
Yes.
this is also x.
X. And then Pythagorean theorem tells us...
X squared plus x squared. So each of those are half of 45.
Half of 45?
Or half of 15, sorry.
15 squared, which is, do you have it memorized?
225.
Okay. So x squared is 225 over 2. Okay. So x is root 225 over 2, which is 15 over root 2. Get rid of the radical. And we get...
15 root 2 over 2.
15 root 2 over 2. 15 times root 2 over 2.
Mm-hmm.
Okay, but let's think about this in terms of SohCahToa.
Okay.
All right. What do we know about, what can we say about this triangle in terms of SohCahToa? So we have 45 degrees is the angle.
Mm-hmm.
Okay. Let's go ahead and write it out. So is sine of 45 degrees. What is that according to the picture? Sine of 45 degrees is?
The sine of 45
So this angle, what's opposite?
is square root 2 over 2.
So, okay, so we know the answer to that because you already studied the unit circle. And you know the value without looking at a calculator. Now, in the triangle, in the picture, what is sine of 45 degrees according to the triangle? What's opposite? Think about this angle. Which one's opposite?
This one, that x.
This x. And the hypotenuse is 15, right? So opposite over hypotenuse is x over 15. Okay, multiply by 15, what do we get? 15 root 2 over 2 equals x. Which should be mildly reassuring that we got the same answer.
Yeah.
Both ways. Okay, what about, and cosine is actually exactly the same, right? So,
Yes.
Ka gives us cosine 45 degrees, also equal to root 2 over 2 from our knowledge of the unit circle, and equals this x over 15. Okay, et cetera, dot, 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 dot. Okay, what about tangent?
Tangent?
In this triangle.
Toa.
Whoops, I wrote H.
Your eraser works now.
Toa. Tangent of 45 degrees. Tangent is new this week. We didn't talk about tangent,
No.
did we? Okay, but it's not a big deal,
No.
right? So tangent of 45 degrees, what is it in this example? What's tangent as a number
Tangent as a number?
in this example? What's opposite over...
O is here, and the adjacent is here. So it should be 1.
Right, it is 1. It's 1. And actually, we can't use tangent in this example to solve for anything.
Why not?
Because there's no...
Here.
Tangent, the variables both show up in tangent and they cancel, right? So there's nothing we can do. One thing to remember though, tangent, do you know about slope of a line?
I think so.
Okay, well if you know about tangent, then you do know about slope. Because if I have any angle in the world, Okay, so I'm going to pretend like this is a graph of a line. But I'm going to leave this, I'm going to call this angle theta. Okay, then typically we would say that the slope, if I say this line right here is y equals mx, the slope is rise over run. M is equal to rise over run. Right?
Yes.
Okay, what's tangent of theta? Well, what's opposite to theta?
That.
Rise.
Over run.
And run is adjacent.
I never
Okay,
made that.
so another way to think about tangent of theta is if a line making angle theta has slope tangent theta. It's just another way to think about it.
Okay.
Okay? You want to do one more of these right triangle trigonometries, or do you think you got it?
I think I got it.
I think you got it too. I don't think we need to do any more.